I welcome everyone to this class. My name is Emmanuel. I am your chemistry teacher on this channel. In today's lesson, we are learning about electronic configuration. But before we begin, there are a few things I want you to do for me. First, get your study book and pen by your side. Also ensure you are in a quiet place. Great to start out today's lesson. Please write down today's date and title, which is electronic configuration. Ensure you have these materials on the screen: a pencil, a book, a pen, cardboard paper, and a periodic table. Please pause this lesson and get them ready. You can get a periodic table from any chemistry textbook or download a copy from any online source. Great, we are ready. By the end of this lesson, students should be able to write electronic configuration of atoms and ions of first 20 elements. Note, this lesson is for students that have covered the following topics: atomic structure and periodic table. Introduction. The electronic configuration describes how electrons are distributed in the various atomic orbitals around the nucleus. There are basic rules that must be followed in writing orbital electronic configuration of atoms. These rules are Pauli's exclusion principle, Hund's rule, and Aufbau principle. In this lesson, we are going to apply Aufbau principle. Arrangement of orbitals. When we draw atomic structure, what we see are shells around the nucleus. The closest shell to the nucleus is K shell, and the K shell has energy level 1, followed by L shell with energy level 2. You have the M shell with energy level 3, then N shell with energy level 4. How orbitals are arranged around the nucleus. We are using this table to see the different orbitals on each energy level. From the table, we can see there is one orbital on energy level 1. Energy level 1 is K shell. The orbital is called S orbital. Under orbital arrangement, we have on the table, we have it as 1s. For energy level 2, there are two orbitals which are called x and p orbitals. Under orbital arrangement, you have them as 2s and 2p. For energy level 3, you have three orbitals which are called x, p, and d orbitals. So you have them under orbital arrangement as 3s, 3p, and 3d. For energy level 4, you have four orbitals, s, p, d, and f. And orbital arrangement, you have them as 4s, 4p, 4d, and 4f. Filling of orbitals. Electrons are filled by obeying Aufbau's principle. Albert principle states that electrons enter into orbitals in order of increasing energy. It means you have to fill the orbital with least energy first before the higher one. It gives you the final electronic configuration of an order of filling of orbital. From the above diagram, it means you fill 1s orbital before filling 2s. Also, somewhere in the third and fourth energy level, it means you will fill 4s orbital before filling 3d orbital. This is because 4s orbital is of lower energy. By following Albert's principle, as shown in the image on the screen, you can see the movement of the electron going from 1s to 2s to 2p to 3s, from 3s to 3p, then to 4s before 3d. Let's look at maximum number of electrons in each orbital. S orbital contains one suborbital. By looking at the equation on the screen, number of electrons is equal to 2 times number of suborbitals. So the maximum number of electrons that will be in s orbital will be 2 times 1, because s orbital has one suborbital. In p orbitals, there are 3 suborbitals. Multiplied by 2, that will give you 6 maximum electrons that will be in p orbital. In d orbitals, there are 5 suborbitals. Multiplied by 2, that will give you 10 maximum number of electrons. In f orbitals, there are 7 suborbitals. Multiplied by 2, that will give you 14 maximum number of electrons that should be in f orbital. We are multiplying by 2 because each orbital or suborbital should contain maximum number of 2 electrons. So in P, for example, where you have 3 suborbitals, each of the 3 will contain 2. So you have 3 times 2, that will give you 6 maximum number of electrons in P orbital. I hope that is clear. So we continue. Now, I want you to write down the following points. S orbital contains maximum number of 2 electrons. P orbital contains maximum number of 6 electrons. D orbital contains maximum number of 10 electrons. F orbitals contains maximum number of 14 electrons. Electronic configuration of atoms. As we already know, atoms are electrically neutral. It means they have no charge. How do we know number of electrons in an atom? Number of electrons are equal to number of protons. Also remember that number of protons is same as atomic number. Let's look at the following work examples. Number 1, write the electronic configuration of element X with atomic number 11. Before you write the electronic configuration, you have to ask yourself if you are working on atom or ion. In this example, we are dealing with atom because X has no charge. Therefore, number of electrons is equal to number of protons. And here we have number of protons to be 11, means that number of electrons will also be 11. You will now try to write the configuration by obeying half-burst principle. See the image demonstrating the half-burst principle. You fill one S first, then you remember that S orbital takes maximum number of 2 electrons from the available 11 electrons we are working with. Then you fill 2s. When you are done filling 2x, you will see that the number of electrons remaining will be 7. When you are done with that, you go to 2p. Then remember that p orbital should take maximum number of 6 electrons. So from the 7 electrons you have after filling 2x, you now give 2p 6 electrons, remaining 1 electron. You now go to 3x and give 3s 1 electron. You don't have up to 2. X is supposed to take 2 maximum, but you don't have up to 2. You give 3s the remaining, which is 1. So with that, you have exhausted the 11 electrons. You now have the electronic configuration as 1s2, 2s2, 2p6, and 3s1. After writing the configuration, you should count number of electrons filled. The number of electrons are written as superscript, that is the numbers on red are the numbers of electrons. Add them up, it should give you 11. Let's see, 2 plus 2 plus 6 plus 1, that is 11. Let's look at second example. Write the electronic configuration of potassium. Here, let's look at the wrong answer first. Atomic number of potassium is 19. We have the 1s2. We are filling the 1s first by giving it 2 electrons maximum, remaining 17 electrons. We now go to 2s, we give it 2 electrons, remaining 15 electrons. We go to 2p, we give it 6, remaining 9 electrons. We now go to 3s, we give it 2, remaining 7 electrons. We now go to 3p, we give it 6 again because it's p orbital, remaining 1 electron. Then we take 3d, we give it 1 electron that is remaining. So we have 1s2, 2s2, 2p6, 3s2, 2p6, and 3d1. What is wrong with the answer? In the answer, you can see that we have 3d instead of 4x. We have to fill 4s before filling 3d because 4x has lower energy than 3d. So in place of 3d, what should be there is 4x. Let's look at the correct answer. The electronic configuration for the correct answer is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. by following the Abbas principle. Remember to count the number of electrons. So let's see, 2 plus 2 plus 6 plus 2 plus 6 plus 1 all is equal to 19. Good. Let's take a little classwork. Question 1. Write the electronic configuration of magnesium with atomic number 12. Answer. Magnesium atomic number 12. Electronic configuration is 1s2, 2s2, 2p6, and 3s2. Is your answer correct? Alright, let's try another one. Question 2. Write the electronic configuration of element Y with atomic number 18. Is your answer correct? Good. Electronic configuration of ions. Ions are formed by gain or loss of electrons. Types of ions are cations and anions. Cations is a positive charge ion formed when an atom loses electrons. Anion is a negative charge ion formed when an atom gains electrons. Number of electrons in an ion. Number of electrons in an ion can be calculated using the formula above. Number of electrons equal to number of protons minus charge on the ion. So we have E equal to P minus C. Let's see how it works. Examples. Write the electronic configuration of sodium ion. Here you can see we are working with ion. To know the number of electrons, you apply the formula given. Atomic number or number of protons is equal to 11. Charge on the ion is +1. Then the formula is number of electrons is equal to P minus C. So you have number of electrons equal to 11 minus bracket +1. Open the bracket, you have 11 minus 1 equal to 10. So the number of electrons in sodium ion is equal to 10. You can now use the 10 electrons to write the electronic configuration. So you have 1s2, 2s2, 2p6. So the electronic configuration is 1s2, 2s2. Classwork. Write the electronic configuration of chloride ion with atomic number 17. Please pause this lesson and get your answers ready. Answer. Number of electrons equal to P minus C, where P is the number of protons and C is the charge on the ion. The number of protons is equal to 17 and the charge on the ion is -1. So we have 17 minus bracket -1. Open the bracket, we have 17 plus 1. That will give us 18. So the number of electrons is 18 and we'll be working with 18 electrons. So the electronic configuration will now be 1s2, 2s2, 2p6, 3s2, and 3p6. Is this your answer? Very good. Please go through these practice questions as soon as possible. Activity. Take your time and complete these activities to better understand this lesson. Activity 1. Copy and complete this table. Activity 2. Create an empty periodic table as seen on the screen. Using the configuration table in Activity 1, make a configuration card as seen on the screen. One card should contain one configuration, then you will have 20 cards for 20 elements. Reshuffle the cards and open it one after another. Place each opened card in the right position on the empty periodic table created. When you complete your activity, snap your work and send it via WhatsApp or via email. The first 10 students to respond will win a prize. Until next time, always stay safe.